Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to the Chemistry Connections podcast.
My name is Agathe.
And my name is Beck.
We are your host for episode number 1, called The Chemistry of Slime.
Today, we will be deep diving into the chemistry behind slime. We will discuss not only what slime is, but also how it's made.
Slime, something we all know and love. Typically, you see it on TikTok or Instagram.
I'm a TikTok slime guy.
Me too. Where someone mixes glue and an unknown clear substance into a bowl, ultimately creating a fun, rubbery material. It is enjoyable to play with, poke, stretch, and make large bubbles with. But what makes slime the way it is, and what allows it to behave that way?
Yes, so slime is made by mixing glue with an activator containing something called boric acid. Now, typically people use borax, a common clothing cleaner. You'll probably find it in your laundry room, mixed with water. And then you add it into the glue and you mix it together and it creates slime.
But Beck, what if I don't have borax? Or what if my parents don't let me use such a strong cleaner, especially when I'm making slime with my little sisters?
So others, like myself, who prefer to avoid the strong chemicals, use baking soda and contact solution, which work just as well and are more accessible and safe. The resulting solution will be the same, and it's just as rubbery and molten, but not sticky, allowing it to be played with for hours, days, whatever. But the interesting question behind slime and how it's formed is why is it the way it is? How is it so molten yet not sticky?
Well, Beck, put a pin in that. We'll talk about it definitely later in this podcast. Another fun aspect of slime is that it can be tailored to anyone's preferences by its color, texture, and size, depending on the different added ingredients one chooses. This versatility makes slime such a popular and customizable activity for many.
So Agathe, what's your favorite thing to add into slime?
Definitely clay for a nice butter slime.
Ooh, I love the texture of that.
How about you?
I'm also a texture person. I add in some foam beads, and it gets a little crunchy, a little crumbly. You hear
that.
it, you play with it. Okay,
But
color.
the question is,
Color,
exactly,
yeah.
color. I'm definitely a pink girl.
I would buy that. I'm a green guy.
I love that.
Okay.
So, going back to your question from earlier, Beck, it leads us to topic 1, how is slime made? Well, it's the formation of the PVA and borax cross-linked polymer. So, that's a lot of scary words, so
Yes.
let's start simple. Glue. Glue is made up of PVA chains, which are basically long chains of CH2, oxygen, carbon, and hydrogen. Then we have the borax ions, which are found in activator. These are made up of borons bonded to hydrogens and oxygens.
And it's kind of like an X shape.
Exactly. When mixed together, these borax ions bond to the PVA chains of the glue together. This creates a really fishnet-like structure, which is called, in chemistry terms, cross-linking. So, Beck, what types of bonds connect these borax ions to the PVA chains?
Well, it's actually hydrogen bonds, which are a type of intermolecular dipole-dipole force that are very strong. So they're formed when hydrogen is bonded to a very electronegative element. So nitrogen, oxygen, and fluorine. In this case, it's oxygen. So the resulting bond is very strong and allows the slime to be formed, but also stay molten and mixed together. The one thing you'll notice, though, when making slime is because of these hydrogen bonds being formed, the slime gets colder. So why is that?
So, interestingly, the reaction is endothermic. This means that it absorbs energy in the form of heat from its surroundings to form new bonds, causing the slime to feel colder, as you said. The endothermic nature of the reaction is due to the formation of these hydrogen bonds, which requires a lot of energy to be created.
Yeah, that's so interesting. Now, When I was making slime, the last time I made slime with my sister, we made this enormous batch.
Yes.
And like when we lifted it up, it stretched so far, and then we dropped it down and created this enormous bubble. And then we popped it, and it got all of my sister's hair, and she was mad.
That's insane. But how did the slime get that stretchy? Because now that I understand there's hydrogen bonds, I thought hydrogen bonds were super strong, which would make it not stretch. But in this case, we all know slime stretches so far. So I'm confused.
That's a really good question, Agathe. That actually leads us into topic 2. Slime's flexible nature is actually due to the hydrogen bonds between the borate and PVA molecules.
No way. That seems so counterintuitive.
Yes, the hydrogen bonds within the slime are strong enough to keep the slime intact when stretched, but also flexible enough to allow movement within the polymer network.
Oh, I see. Wait, but the last time I was making slime with Mr. Johnson, he told me to add in lotion, and he said it would make it even more stretchy. I told him that didn't sound right to me. Who was right, Beck?
So, Mr. Johnson's actually right in that case. Adding lotion to slime introduces glycerin, which interacts with the hydrogen bonds and makes it stretchier.
Ugh, whatever. What even is glycerin?
So glycerin is an odorless carbohydrate liquid that has a sweet taste and a syrupy consistency. When glycerin occurs naturally, it happens in plants through the fermentation of sugars. But most of the glycerin nowadays is made in factories. And the glycerin makes the slime stickier and stretchier because it is able to form hydrogen bonds with the PVA.
Oh, I see. So glycerin replaces some of the existing hydrogen bonds, instead hydrogen bonding to the PVA, making the whole substance weaker and more flexible, but not too much that it becomes a liquid disaster like you and your sister.
So true. So yeah, the slime, the glycerin makes the slime become even stretchier because the weaker bonds can be extended further while still maintaining the overall structure of the slime. Thus, the stretchiness is a balance between the strong, flexible bonds and the weakened bonds introduced by the lotion, providing both resilience and extensibility.
That's so cool. I love that.
We clearly both love slime so much, so why did we decide to make a podcast episode about it?
Well, Beck, we both love the idea of chemistry behind slime because it's such a simple thing to do and make, and all kids around the world love it. However, we never really thought about why the chemicals react and how they react to turn these liquids into solids without using heat or any outside sources.
Yes, so true. And also we feel that learning the chemistry behind things that people actually care about and actually find fun will help them remember these concepts that you learn in school much better and easier because it's something we're passionate about.
Period. Thank you for listening to today's episode of Chemistry Connections. For more student-run podcasts and digital content, make sure that you visit www.hvspn.com.
Thank you so much.
Goodbye.